Okay, so this is the video answer set for set 3 for the 10 questions for GCSE. Now, another set of skills here. Some of them have already appeared in previous sets, maybe just in a slightly different way. They will all be skills that could easily you could easily be tested on to see to get you ready for your GCSE grade 4 or higher. So this first one, simplify. That just means tidy it up, really, another word for tidy it up. Now this actually comes from x times x times x. That's your first set here. And then it's been multiplied by x times x. So this is the long way of doing it, just to show you where this comes from. But basically, you can use your rules of indices. And the rules of indices are when the same base letter or base number here. Now, in standard form, this could be a 10 and a 10. But here in algebra, it could be any letter at all. When you're multiplying two base numbers the same, the rule is to add those indices together. And if we spread it all out like this, longhand, we can see that we've got 1, 2, 3, 4, 5, 6, 7 powers of x. So the final answer is going to be x to the power 7. Okay, simple way here, 3 plus 4, x to the power 7. So the next one, expand and simplify. Now, it could be that you prefer to do this by the loop method. So you would just have your x times your x and your x times minus 5. And then don't forget to do the bottom two loops as well. Minus 1 times x minus 1 times minus 5. But that, sometimes people get lost with this method. So I'm going to show you with a grid method. This just means you put each bracket written out on one part of the grid. You've got an x and you've got a minus 1. You've got an x and you've got a minus or negative 5. And they're all being multiplied together. So we've got x multiplied by x gives you x squared. X multiplied by minus 1, that's minus 1x, but we always write minus x. So it's the same as minus 1x, it's just written as minus x. Minus 5 times x, you get minus 5x. And then here, minus 5 times minus 1. Well, let's just write at the side here, minus 5 times minus 1. You've got a negative times a negative. Now, when you've got multiplying or dividing with negatives, you can use that little rule. Negative times negative will always give you a positive answer. You've got 5 times 1, so it turns to just be 5. So that's going to leave us with positive 5 in that corner box. You've now got to bring out all of those 4 terms that are in the box. And if you've done these 4 loops, each loop would give you a term that came out. So you've got x squared, you've got minus 5x, you've got minus that 1x minus x, and a positive 5. So you could even write a little plus here so you know it's a positive 5, not get confused with the negatives. Now we tidy it up, we simplify it. So that can be simplified as x squared minus 5 minus 1, if you like, is going to be minus 6x. And then that positive 5 becomes plus 5 on the end. Okay, this one, factorize, means to put this expression back into brackets. And because it's got a squared, a linear term there and a constant, you can tell it is a double bracket one. So we are going to put it back into brackets, and it's going to go into 2 brackets like that. Now some of you might be able to spot straight away and put it straight back into brackets like this, which would be amazing, but many of you will not be able to do that. Now when you have these brackets and you multiply them out, you expand them to start with, you'd have your x there and you'd have an x there. So when you expand it with the loop on the x and the x, you'd get the x squared bit. So that's almost taken care of already. Now this number 12 comes from multiplying the 2 numbers, the 2 integers. So when you do that number times that number, you get 12. So that's our starting point here. We need to think what times what, okay, could equal 12. And so we need to write down the list of multiples. So the first one is 1 times 12. We could have 2 times 6. We could have 3 times 4. And that's it. If there had been negatives in here, you'd have to consider any of these pairs with a negative or with 2 negatives to get the same result of positive 12. Okay, so it'd be 2 negatives if there'd been a negative over here. Luckily, there's no negative this time. So what are our list of multiples that make 12? So that came from doing that one times that one. Now this 7x comes actually from having this many x's added to this many x's. So that comes from this loop here, and it comes from this loop here. We add those two bits together when we tidy it up. So that's where we get that 7 from. So we're looking at a pair of numbers here. When you add them together, you get 7x. I'm just going to show you the grid method as well, because this might make it a little bit clearer for some of you. So we've got x there and x there, and something here and something here. So the x times x gives you x squared. That's sorted. Something times something gives you the 12. I'm just going to change my colour quickly so I can show you more easily something. Okay, so if we have this number times this number equals 12, we've got this number times x, which give you something x. Okay, and this number here times this x would give you something x. Now, when you tidy this up and write it all out, you'd have x squared, you'd have plus something x, okay, plus the other something x plus 12. And if you look at this, this is a sort of a grid here. In the middle, where the two grid lines would cross, if you drew the full grid in, you're adding these two red bits, okay? So times together makes the 12, added together would make that 7. Just change the colour again. Okay, so we've got to think which two add to make 7. 2 and 6 is 8, 1 and 12 is 13, 3 and 4 makes 7. So let's put a 3 in here and a 4 in here. So now let's fill those gaps in. 3x, 3 times x gives you 3x, 4 times x gives you 4x, 4x plus the 3x, so 4x there and 3x there. When we tidy that all up, we get exactly what we are looking for. We get 7x and then add the 12 on the end. So we've got exactly back to where we started. So this is like a little check here. So this isn't the answer. This is finding out if it works. So the answer is going to be, this is a positive 3 and this is a positive 4. So the answer is whatever is on the top of our grid. So we can now put that grid back into brackets. X plus 3 is one part of the grid, and x plus 4 is the other part of the grid. And we've proved it works by multiplying it out. So that is your final answer. X plus 3 times x plus 4 is that first expression factorized. Okay, so simultaneous equation here. We are looking, first of all, to find a matching set of terms. So this is just one way of dealing with it. We can say we want to find a snap. That's our first step. Once we've got that snap, we are going to, what I call, zap the matching bits. And then once we've zapped them, we are going to then use a substitution method. And then finally, you'll be very sensible, very wise to do the check to make sure both our x and y values work. So say looking for a snap, we're looking to have matching x terms. Okay, they could be different signs in simultaneous equations. That's perfectly okay. Or matching y terms. Okay, now I'm going to use the x terms just because they're both positive. So I'm going to rewrite these out, and I'm looking to put sort of the bigger terms on top, because when you've got the same signs, positive 2x and positive 2x, okay, same signs, subtract the lines. Let's write this up here. So if you've got the same signs in the snap, okay, in your snap, then you subtract the lines. You'll see what I mean when I go through this in a second. Okay, subtract the lines. So we've got 2x, yeah, plus y equals 10. Lining it up, I've got 2x minus y equals 6. Now you could label these as equation 1 and equation 2. So we would do that. So same signs, I've got a snap. I've made a snap. Now, sometimes you've got to scale up one equation or the other to get a snap. Here you've got one already. So if this hadn't been a 2x or hadn't been a 1y, we may have had to have doubled the whole row to get a snap of a 2x, okay? So that's a step that you're not doing here that quite often you may have to do. So we're subtracting these lines. 2x, take away 2x, we're left with no x's. You could write it there to, show that you've done it, but we don't need it. Cross it out. So now we've got positive y. Just write this to one side. Positive y, take away a negative y. Positive y, take away a negative y. That's why you write the take away bit here to make it really clear, and I suggest you write it at the side. Okay, so if we're taking away, just to change my colour again. Okay, if we take away a negative number, when you've got the subtraction bit with negatives, it's about what happens to the actual operation. What happens here? This is going to make a plus. Okay, it's going to make an addition. All right, so back to our colour. So we have got y plus y. We're going to get 2y there. So this bit becomes 2y. We've got 10. Take away 6. Again, a good habit to get into is to write that calculation at the side. It's positive 6, so it's just like a nice little calculation there. We get 4. And the final bit to do, we've got 2y. If 2y equals 4, then a single y, we're actually dividing both sides by 2 to get rid of this multiplying by 2 bit. So it's being multiplied by 2. We're undoing that to get a single y. Same thing to both sides, balancing it out. So divided by 2, we get y equals 2. Okay, so that's our zap done as well. Done our snap, done our zap. Zapping it is getting rid, this is a zap bit here, getting rid of this matched up pair. So now we're going to substitute. So we're going to take one of our equations. I'm going to take the positive one again. 2x plus y equals 10. I'm now going to substitute this y value that I have just found into the equation that we started with. So that becomes 2x plus 2 equals 10. So we want to get the x on its own. So we need to get rid of that 2. So I'm going to take the 2 away from both sides. Take the 2 from both sides. And then I end up with, come up here, and then I end up with 2x is left. I've got rid of that 2 on the left-hand side. 10 take away 2 is 8. Okay, so if 2x equals 8, then a single x, again, dividing by 2 on both sides because I'm multiplying by 2 there. So I'm just doing the same thing to both sides, balancing out the equation using inverses. I get 4. Okay, so I've done my substitution, but I've now found an x value and I've got a y value. Now, I could just leave it there, but that's a bit risky because especially when there's negatives involved here, it can get a bit messy and you could easily have slipped up at this stage here. Okay, so we're going to check it. So the check is to use both of these values x equals 4 and y equals 2 and substitute them into the other equation we've not used yet for checking. So I'm going to go for another pen colour. Right, so we're going to use the second equation, 2x minus y equals 6. So that 4 is going to go in, and this y equals 2 is going to go in. So I've got 2 times 4, and then the y is worth 2, take away 2 equals 6. Now, if this works, we know we're right, we know we're correct. So that's 8, take away 2. Does it equal 6? Yes, it does. So these values must be correct because they work in here. And that is full marks, usually 3 or 4 marks. So full marks for that question. Okay, now this question is a bit of a common sense question. Think about if you had less workers doing a job, it would take them longer time to paint this fence in this case. If you had more workers doing the job, it should take them less time in total to paint this fence. We are making an assumption here, otherwise we just couldn't calculate it. We have to assume that every worker works at the same rate. And as with sometimes we have more workers on a job, they might get in each other's way. We can't assume that's going to happen. We have to assume they're all working at the same rate. So this is actually an inverse proportion question. And we can work it out by actually lining up, writing down and lining up our, sorry, it's gone back the wrong way there. Okay, lost my pen now. Okay, sorry about that, technical hitch. So I'm going to do by lining up, label, line up, and link, I call this method. There's your workers, and you've got your hours. So get your common sense hat on. We've got 4 workers. It takes them 6 hours. Now with this one, we could actually just jump straight from 4 to 8. Okay. Be very careful because you might go, oh, I'm doubling that, so therefore I'm going to double the 6 hours. No, because more workers should take them less time. But I'm just going to show you a method that would help you get there when you haven't got a nice doubling link like that. So this is a bit like when you do recipes, you need to find out how many grams of something for 1 cake, and you've got a recipe for 6 cakes, and you want to make, let's say, I don't know, 13 cakes. So we're going to come back and get how many for 1 worker. How many hours should it take 1 worker if it takes 4 workers 6 hours? So we're going to use our link to get from any number back to 1. You always just divide by the number you started with. So 4 divided by 1 gives 4 divided by 4 gives you 1. And going that way, 1 times 4 gives you 4. On this side, though, we are going to do the opposite, the inverse of this side over here. Now, usually these links are exactly the same, but this is an inverse proportion question. As one thing goes down, the other thing goes up. So this is going to be times by 4 here, not divided by 4. So we should then have 24 hours. So it's going to take this one person 24 total man hours or woman hours to paint this fence. Okay, so we are now going to use our 1 worker to get to 8 workers. So 8 workers there. Now to get from 1 to any number, we just multiply by that number, so times 8. Now because it's inverse proportion, we are going to do the opposite. So we're going to divide by 8. So 24 divided by 8 is going to give us 3. Okay, so let me just change the color and then show you what you could have done, which you may well have done straight away if you saw that link. Is to get from 4 to 8 here, you can go in one jump. You can say, okay, double that. Let's times that by 2. Okay, but over here, as the number of workers increases, the number of hours should decrease. Common sense hat again. So we're going to divide by 2 here. So 6 divided by 2 gives you 3. It matches this other way of doing it. But on other questions you get in this set in the next few weeks, you will probably need to come back to 1 and then build up to the number you're looking for. So the answer to the question, how many workers, it would take them 3 hours. It would take 8 workers 3 hours. And if they ask you, which they might do, for a statement as to what assumption have you made, you're assuming they all work at the same rate. Okay? A constant rate, same rate. Okay, a measure is given as 200 centimetres rounded to the nearest centimetre. What is the upper bound? Another way they could ask this question is, what is the maximum measurement this, whatever it is, this line, this tape, could be? So they may not even say the words upper bound. They may actually say, what's the maximum? What's the longest it could be? The maximum or the longest? Okay, so they may not even give it away as an upper bound, or this is also part of an error interval question too. So the first thing to do is look at what's it being rounded to. It's being rounded to the nearest centimetre, and because it's rounded to the nearest centimetre, we're going to be going up 1 centimetre, and we'll also go down 1 centimetre here, so we can deal with the error interval thing as well. Best way of doing this, one way of doing this, but I think it's a good way, is to draw a number line. They've given you 200 centimetres. Okay, that's what they've marked it out at. And our rounding is to the nearest centimetre. So I'm going to add that 1 I've shown up here. I'm going to add that 1 on and get 201 centimetres. And just for the purposes of making this in a fuller question, 199 centimetres is me going down 1 over here. So nearest centimetre, up 1, down 1. Now, the bit we actually want is the number right in the middle. So bang in the middle. So we want to have this bit here, because if we had 199, that's what it's rounded to, 199. If we had 199.2, it would round down to 199. 199.3, 0.4 would round down to 199. So this halfway mark between 199 and 200, which is 199.5. Now, if you had 199.5, you need to round it to the nearest centimetre, it would round up to 200. So that is what we call our lower bound, or our minimum, or the shortest this line or this thing we've measured could be. Okay. Same on this side, we go bang in the middle. Halfway between these two is 200.5. And this is what we call the upper bound. Now you might be saying, but if you had 200.5, you would round it up to 201. Well, yes, you would. But the thing is, with bounds, we are allowed to keep it tidy and make it 200.5. Because we could have 200.1, 0.2, 0.3, 0.4, 0.49, 0.499, 0.4999999. So this could actually be 200.499999999 could be your upper bound. And that just looks messy. So in maths, we like to be tidy. So our upper bound would count as this one here. Okay. Now, the other thing they could ask you to do, just change my color quickly while we're on this topic. It's not part of this, this question for this mark, but the other thing they might ask you about is an error interval on these sorts of questions. And they usually set it up for you. Okay, they usually set it up for you. So the error interval would have your thing, whatever it is. X is your thing you've measured, and it's got symbols like this. Now you've got 2 different symbols here. This takes account of the fact that 200.5 would round up to 201. Okay, 200.499999 would round down to 200. So we're not including the 200.5, okay, but it is the upper bound. It doesn't include it, and that gets us away from that 200.4999 business, okay? And then the lower bound, other parts of the error interval, would just go on here, 199.5, okay? But for the purposes of this question, they wanted the upper bound only, So the answer to this question is 200.5. Okay, fraction calculation. Now, a multiplication in this format is the easiest fraction calculation you can have, really. One of the easiest, apart from a simple adding, let's say, I don't know, 2/8 plus 3/8 with the same denominator. It's a pretty simple calculation. So what we need to do is we just literally multiply across the top two, and we multiply across the bottom two. So we get 2 times 6, okay, equals 12. And we get 3 times 7 is 21. So simple, times the top, times the bottom, job done. If you had had something like 2 2/3, okay, times, let's say, 1 6/7, you would first of all need to make that into a top-heavy fraction. So we'd need to be getting these two whole things into thirds and then plus the 2/3 there. So that's another skill that isn't in this set, so I'll leave it for now. You could always ask your teacher if you need help with that. But if it comes up in this set, but if you've got a mixed number like this, you've got to get that two whole ones on top with those 2/3. So just to quickly show you that, it's not going to go into too much detail. You've got two whole pizzas, let's say, and because the other ones are thirds, this bit's thirds, they've got to be cut into thirds. So I can't draw the thirds now for you very well. Oh my goodness, that's rubbish thirds. So there we go, cut into thirds. Two whole pizzas gives you 1, 2, 3, 4, 5, 6 thirds. Same as doing 2 times 3, that gives you 6. But then add the 2 extra thirds on. You'd have 8 thirds for this side of the fraction, for example. And that's what you need to do if you've got a mixed number. I will just show you one other skill here because I know it comes up in another set in this group of questions. So another skill, very common one to have, if you had 3/5, let's say, divided, okay, by 3/4. All right, this you need to use the terms KCF, bit of a wonky Kentucky Fried Chicken, KCF rather than KFC. So keep, change, flip. You're going to keep this one as it is. Okay, you're going to change the sign to its inverse, and you're going to flip this part over. So we keep this, we get 3/5. We change that division sign to its inverse, we get multiplication. We flip this fraction over, we get 4/3. Now we are in the same situation as up here. We now just have to do top times top, bottom times bottom, sorry, numerator times numerator, denominator times denominator. So that would give us 12 over 15. And that can actually be simplified down. They'll both divide by 3, so we get 4/5 as the answer there. Okay, one significant figure. Round this number to one significant figure. So this is different to decimal places. There are times when it gets tricky if you've got a decimal in there, it's 0 point something. But at the moment, it's quite a nice one with just a whole number. So significant figures. Imagine this was a check, and I said you can only keep one value on this check. You want to have the most significant value, the most important number on that check. If there was a pound sign in front of this, what would you choose? And hopefully you wouldn't choose that 9 on the end, okay? So we're going to say you can only keep one column, if you like, one value on this check. So hopefully you don't go for the £9. Hopefully you're going to, unless you want to give the money away, you're going to choose the 4. Just trying to, so I've got rid of that now. Okay, sorry about that, another technical hitch. So we've got our pound sign to help us out. Think about which is the most important value. So this £9, not worth much at all. But right down the other end, we've got a 4 in the tens of thousands column, so it's 40,000. So we know we're going to actually finish here. We're going to finish at this number here. We only want one digit in our answer, one digit of any value in our answer. So we have to look next door, look at the next number down to help us decide if we're going to round up to 5 here or keep it down at 4. Now, as it's a 5, hopefully you do know that if it's a 0, 1, 2, 3, or 4, you keep it down. That means keep the number that you're looking at down. Don't take it down to a 3, it would stay at 4. Okay. And if you've got a 5, 6, 7, 8, 9, you would round it up. Okay, it's about which £10,000 is it nearer to? Is this nearer to £50,000 or is this number nearer to £40,000? Okay, so the 5 is on the round up bit. 45,639 is nearer to 50,000. Again, you could draw a number line if you wanted to. So the answer to this is 50,000. Now the other numbers must go to 0. Don't just go putting 5 as your answer. 50,000 is it rounded to one significant figure. And sometimes you get that written like this. People will write 1SF or 1 sig fig. Okay, so long as you have said, if you have asked you to round something, you might be able to say what you've rounded it to, and that is to 1 sig fig, 1 SF would be perfectly acceptable. Okay, now this question, does the point -1, 4 lie on the line y equals 5 minus x? This has caused a lot of problems in the past, but it's not too bad at all. Now this here is just a pair of coordinates. So the first thing you need to do is just label which one is x and which one is y. Now this is something that also gets done when we're trying to find a gradient between 2 points, and you've got 2 pairs of coordinates, and you label the x and you label the y, and you find the difference between x and y. So it's very similar to things we've done in the past with finding gradients from pairs of coordinates. Here, though, only one pair of coordinates, and I want to know if it's on this line. So this is a straight line. There's no squared. It's just a linear. It's just got a single x there, not a squared x. So we're going to do some substituting. So I'll write this out again. Okay, so I'm going to substitute this y value here, which is 4. I'm just going to put that instead of that y there. So there it goes, 4 equals 5 minus, now this x value of -1, got to include the sign with it as well, is going to come down here instead of the x. Now it is a subtraction. It started out as a subtraction, so that's got to stay. That is not anything to do with the -1. It's subtract -1. Okay, so we now need to get this worked out. So 5 minus -1, so taking away a negative number is the same as adding. So this lot becomes an add instead, using our rules of negatives. 5 plus 1. So if this makes sense, if it works, then we are correct. This point works for this equation. But look at that. 5 plus 1 is 6. So no, it doesn't equal 4. So no, it is not on that line. You must say no. Now, because if you said yes or no, 50-50, you can't just get away with saying no. You've got to show this sort of working out. Okay, so that's substitute. You can't just say, oh, I did it in my head and put a no. They have to see what's going on here in your working out. But just a case of labeling x and y, substituting them in that equation you've been given, and seeing if it works. And remembering that it is a subtraction, but you've got a -1 going in there. So subtract a negative becomes an add. So it doesn't fit that line. Okay, so this one, we have got a side of a triangle, another side, and another side, and it's a right angle triangle. So when we've got this set up and we're trying to find a missing length, this is a Pythagoras question. Okay, Pythagoras or Pythag question, Pythagoras theorem. So the Pythagoras theorem is, I think most of you all know it, a squared plus b squared equals c squared. Now, which one's a, b, c? C is always the longest side. Okay, so this is our c. It's always the one that's opposite that right angle there. The other two can be either way round. Let's just call this a. Let's call this b. A, B, C. So again, once again, we're going to use substitution. So A is 10. So let's put that under here, 10, and it's 10 squared in our formula, plus B squared. We don't know what B is yet. We're trying to find that. Equals 11 squared. Okay. So we're trying to get B on its own. So what we need to do is get rid of this 10 squared. We've got to balance it. Take that 10 squared away from both sides. Okay, we're taking it away from both sides. If we take it away from that side, we get rid of it. So we're left with b squared. And I'm going to actually write it on here because I need to. So take away 10 squared. What I now need to do is get some values in here. So 11 squared is 11 times 11 is 121. Take away 10 squared. So 10 times 10 is 100. So b squared is going to be the result of that calculation. So b squared is 21. If you now put 21 up here as your value for x, that would be a bit silly, a bit of a nonsense answer, because this we've just decided is the longest side at 11. So that cannot possibly be 21. You've missed a little step out here. Just change my pen colour. So hopefully you can realise what it is you need to now do to finish this off. So we need to do square root of both sides. So just put that there. We're square rooting both sides, balancing it out, always balancing out what we do. Okay. So we square root this side, b side, we lose that square. That's what happens there. We're unsquaring it. And then we end up with square root of 21. And that is our final answer if it's a non-calculator question. Now, just out of interest, they may ask you, what is that approximately equal to? So we can work that out. We can get an approximate answer to that. If we have think about our square numbers, we've got 16 is the square number nearest to 21. Okay, here's our square root of 21 somewhere here. And then we've got 25 is another square number, 4 squared and 5 squared. Okay, so if this is 4 squared and this is 5 squared, then 21 must be 4 point something squared. So a good approximation would be 4.5, 4.4 or 4.6, any of those, anywhere along that scale. 4.5 squared is the approximate answer. But we are okay with the left as a square root because it's a non-calculator. Okay, so that is your final answer for that question. Okay, so here's the full list of answers. I haven't got the Pythagoras one on there, but I'll write it on for you. So full list of answers. We decided this one was actually square root of 21, didn't we? Okay, so x equals the square root of 21 there. There's just one thing here to add. Now this question here, when we did it in the model answers, we did 2 6s are 12, and then we did 3 7s are 21, and didn't remember to simplify down. So you would lose marks there. So simplify down, both of them will divide by 3. Okay, divide by 3 on the top, we get 4. Divide by 3 on the bottom, we get 7. Okay, so it's the last bit of simplifying to do at the end there. So apologies if you were shouting at the screen earlier saying I hadn't simplified. I hadn't simplified. Okay, and so just to finish off with, there is a PDF version of these model answers. It's just a PDF version of this PowerPoint. If you ask your teacher to upload it to the class materials section, that might be something easier to refer to, or email it to you. Okay, good luck with learning some new skills.